Hi, my name is Guiomar. I'm the head of the Neuroimaging group at Cajal Institute at the Spanish National Research Council. And in this third block, I'm going to talk about research data management. In this section, I will show some open resources for research data management, and this refers to how data are organized, maintained, annotated, tracked, stored, and accessed throughout a research project. I will talk about data standards and annotations, and my colleague Jaroslav Halchenko will continue with some tools for data tracking. Why are standards needed? This could be a potential situation in a lab. Hey, I need to ask Pedro about this old data. There's so much more we can do with it. But meet Pedro. He doesn't longer work in the lab. So this researcher will need a lot of help. Do you typically feel confident in data that you didn't collect yourself? Or have you tried to reanalyze someone else's data? Or have you ever tried to reanalyze your own data just a year later? If you have tried to do so, you will see how difficult it is. The problem is data is organized differently between people, between institutions, and even within a lab. So this produces a lot of misunderstandings, waste of resources, and poor reproducibility of results. That's why the brain imaging data structure bits emerged for neuroimaging data. Bits is just a standard to store, organize, and share neuroimaging data. Bits, it's based on simple file formats and folder structures. It's important that together with the data, we also store all the metadata in a JSON file next to the data. So in these JSON files, we store some fields, some data like modality, magnetic fields, imaging frequency, manufacturer, and all these kind of details that otherwise will get lost or would be very difficult to obtain once the data is stored and some time pass. What's important about these JSON files that store all the data, metadata, is that they are readable by both humans and machines, making things super easy. This is the bits naming convention. It starts with the subject, then the data type. All the files are named following subject, entity, suffix, and extension. Bits is a community effort, and all the specifications are the results of discussions between the community, and they are openly available on the website. In bits specifications, when they indicate the fields that the JSON files must have, they are also some suggestions about if the fields are recommended, are required, or are optional. This contributes to avoid having a highly organized but useless dataset. The good thing about bits is that once you've seen a bits dataset, you've seen them all. OpenNeuro is a neuroimaging database that for datasets that follow bits specifications. In the course, I will guide you through some of these datasets, and we'll see that they are all organized in the same way. So it's really easy to understand what's behind them and all the details. This is how we typically organize data as it comes out from the scanner, and this is how bits organize it. So welcome to the Marie Kondo of neuroimaging data. There are multiple tools to facilitate the use of bits, starting from converters that just gather some of the raw data and transform it into bits, bits organized dataset, and keeps all the metadata together with the data. There's also a very important tool for bits, which is the validator, which checks if the dataset is following the specifications. And if there are some fields that are not included and should be included, it raise some errors or warnings. There are also some general tools to interact with the data, like PyBits and BitsMATLAB. And finally, some bits apps, which are just analysis pipelines inside a container. We will see some more information about containers in the data analysis part of the course with Pierre. In the course, I will also guide you through a Python notebook to convert some MEG data into bits using mnbits, which is a Python tool developed by the MNE team. And we will also play a bit with the EEG bits, which is just a tool to convert your MRI data into bits just using the interface. Bits started in Stanford, mainly focused on MRI in Raspolrak lab. And it's extended to many other neuroimaging modalities like MEG, EEG, intracranial EEG, genetic information, arterial spin labeling, PET and microscopy, and there are many more ongoing extensions. BITS is being adopted by hundreds of institutions worldwide, so I think it's a very good option to organize your data following BITS. Now let's talk about metadata and data annotation. Many times without a standard, it's very cumbersome and error-prone to annotate your data or mark your events or name your events. So that's why the Hierarchical Event Descriptor, HID, initiative facilitates this endeavor. It's just a structured vocabulary for annotating data. And similar to bits, this is thought to be human and machine readable. HID is just a tool to annotate event files, which is fully integrated with bits. So once you have named your files, you can have your HID tags inside bits. Imagine this presentation of a face image. We'll have a basic HID annotation, which will describe, okay, this is a sensory event. This is a visual presentation of an image that which has face and which has hair. This is the path name, and this is the condition variable, which is a famous face. These basic HID annotations can be expanded into full paths, which will allow hierarchical relationships. For example, the sensory event will be under the category event, and then the visual presentation will be a property, a sensory presentation, visual presentation. These are an example of some of the categories you have in HID. And yeah, this is a very nice tool that you can use to describe your events. In the next part of the talk, Jaroslav will present a bit more about data management and tracking. See you in Montreal.